Good morning, everyone. Is my screen and voice clear?
Yes, sir.
Yeah. So first things first, now regarding the issue on the Friday class, Epsilon-NFA for string acceptance, na, we have a little debate for this, right? Whether only exclusive final state or any one occurrence of final state. So I had verified it, and also checked it against some senior faculty as well. So any one occurrence of final state is enough to declare the string acceptance. So this is the clarification from my end. So in Epsilon-NFA string acceptance, we have seen 0, 1, 2. So for this string 0, 1, 2, after the last input 2 is scanned, we will be reaching Q2, which is the exclusive final state. So we call it as accepted. In the case of 0, 1, 1, for the last one, I think it's coming as Epsilon-Closure of Q0. Okay. Sorry, Q1. Epsilon-Closure of Q1. Okay. It will be Q1 and Q2. So finally, you're getting Q2 final state as well as another state also. But this is also valid now because there is one occurrence of final state. That means there is a path that we can reach up to the final state, right? So 0, 1, 1 is also deemed as accepted. Okay. So need not mandatorily you should reach the final state, but even there is one occurrence of final state, you can call it because it's after an Epsilon-NFA. Okay. So from a path, you will be reaching to Q1, you will be reaching to Q2 also. This is a valid path, which is going to the final state. That means from this 0, 1, 1, there is a path you can reach up to the final state. Okay. So not exclusively the final state, one occurrence of final state is enough for us to deem it as the string to be accepted. Okay. Clear, everyone? Yeah. So Friday 2 to 2:45 will be the flat examination for all the third years. So I'm very happy that HOD ma'am has obliged our request from the flat faculty to keep the exam at the last possible start. So until the Friday session, we will be dealing with the syllabus. Not that it will be covered in this session or next session, we can have a revision. So it's not the thing now. Okay. So until the Friday morning session, we will be dealing with the topics. So kindly plan the things accordingly and do prepare well. Already I had shared the video lectures with the CRs, both the CRs. I hope you have gained access to the folders. So every day after the session is done, I will be uploading the session recording. So any issue or any doubts, kindly do revisit them. Okay. So we are done with DFA. Are done with NFA. NFA to DFA conversion is done, and Epsilon-NFA with string acceptance is done. Okay. So these are the 4 topics that we have so far covered. Apart from the introduction, we need to see Epsilon-NFA to NFA conversion and Epsilon-NFA to DFA conversion. So that's all for the Epsilon-NFA. As I have told you, Epsilon-NFA, we have 3 models. String acceptance, Epsilon-NFA to normal NFA, and Epsilon-NFA to directly DFA conversions. Okay. So in today's session, we'll be seeing the Epsilon-NFA conversions. It's a bit easy compared to NFA to DFA conversion. Very easy. So just listen. So first up, I will take the Epsilon-NFA to DFA conversion. It's pretty simple. So given an Epsilon-NFA, you are asked to convert into corresponding DFA, Deterministic Finite Automata. So I'm taking a basic Epsilon-NFA, Q0 on A, Epsilon Q1 on B, Epsilon Q2 on C. This is the final state. The same previous one, instead of 0, 1, I have taken ABC. Okay, this is a standard example. Okay, so this is an Epsilon-NFA. For this, you are asked to corresponding DFA. Okay, so step 1. So for Epsilon-NFA, we had a little advantage. Okay, whether it is string acceptance or DFA conversion or RFA conversion, the step one is same. Okay, you need to compute epsilon closures. Okay, so this is a central concept in the Epsilon-NFA problems. Okay, even in the main exam itself, if you are unable to do the conversion, just if you could able to complete the epsilon closures, there is a chance for you to get 2 to 3 marks in the worst possible case. Okay, so given Epsilon-NFA, first compute epsilon closures and keep it aside. We need the data, whatever be the problems. Okay, so first up, compute epsilon closures. So epsilon closure of Q naught. What will be the epsilon closure of Q naught?
Q0, Q1, Q2.
So Q naught, Q1, Q2. So epsilon closure is a set of all states that can be reached from a state over the input epsilon. And as I have told you, every state on epsilon goes to itself. So from Q naught, you can reach Q naught. With epsilon, you can reach Q1, and there is another epsilon that can be reaching up to Q2. So epsilon closure of Q naught is Q naught, Q1, Q2. Now epsilon closure of Q1.
Q1, Q2.
Only Q1, Q2. Epsilon closure of Q2.
Only Q2.
Only. Okay, this is step one. Now what you will to do is this states, you call it as A1. Or assume you have merged these three states and call it with a new name A. In this two, we call it B. In this one, we call it C. Okay, so the states with epsilon closures, for every state, you call it with one new name, A, B, C. It is okay if you call it with a new name, or if you merge it like a single state and leave it, that's also fine. Okay, but better rename it as A, B, C. Okay, now this Q0, Q1, Q2, assume it as merged as one state, and the name of the new state is A. Q1, Q2 merged as one state, assume it to be B. Q2, a single state, assume it to be C. Okay, so in DFA conversion, compute epsilon closures and rename the states. Okay, the final epsilon closures, rename the states A, B, and C. Okay, now step two. Traverse new states over the input. That's it. The same methodology. To compute the epsilon closures, we traverse over the input. That's it. So traverse the new states over input. So what is the input? A, B, C. A, B, and C. So we need to traverse the new states. See this new states. What are the new states? A, B, and C. Not Q0, Q1, Q2. So we need to traverse the new states over the input A, B, C. So delta. What is the first new state? A. What is the first input character? Clear, everyone?
Yes, sir.
We need to traverse the new states over the available input. So my first new state is A on A. So this is pretty much same. Epsilon closure of delta. What is A? Q0, Q1, Q2. So Q0, Q1, Q2 over A. The same goes. Q0 on A, union Q1 on A, union Q2 on A. So epsilon. What will be Q0 on A? Q0, Q1 on A, nothing. Q2 on A, nothing. So it's epsilon closure of Q0, which is Q0, Q1, Q2. Clear?
Yes, sir.
Everyone clear with this? Now, whenever you see Q0, Q1,
Sir,
Q2,
sir, again.
assume it to be A. Yeah, Tarva.
Sir, epsilon closure.
Should I repeat this step again?
Not the whole step, but we got epsilon closure of Q0, right?
Yeah. Q0,
After
Q1,
that,
Q2, which is A.
Acha, okay, fine.
Same, the same one. Okay.
Yeah, fine, sir.
So it is clear that for the new state A over the input A, ultimately you are reaching the same state itself. Itself is like a self loop A. So check A on B. That's epsilon closure of transition, the same Q0, Q1, Q2 on B. There's epsilon closure of Q0 on B, nothing. Q1 on B, Q1, Q2 on B, nothing, right? So it's ultimately epsilon closure of Q1. What is epsilon closure of Q1? B. You can directly write B. It's actually Q1, Q2, but directly you can reach it as B. Okay, let's not confuse me. So Q1, Q2, which is B. Clear, everyone?
Yes, sir.
So delta A on C. So the epsilon closure of delta, the same Q0, Q1, Q2 on C. So it's ultimately epsilon closure of Q0 on C, no path, Q1 on C, no path, Q2 on C, Q2 itself. So epsilon closure of Q2, which is Q2. Now I'm calling this Q2 as C. Clear, everyone?
Yes, sir.
For each state, traverse over the input. Now, this is with A. So for B, B on A. It's epsilon of delta B. What is B mark? Q1, Q2. So Q1, Q2 on A. It's epsilon of Q1 on A. Nothing. Q2 on A. Nothing. 5. So it is 5. Okay, no path. B on A, there is no path. Okay. Delta B on B. Epsilon closure of transition of same Q1, Q2 on B. Q1 on B, Q1 itself. Q2 on B, no path. So epsilon closure of Q1. What is epsilon closure of Q1? B. Delta B on C. It's epsilon closure of delta Q1, Q2 on C. Q1 on C, nothing. Q2 on C itself. So epsilon closure of Q2. What is epsilon closure of Q2? Q2, which I am calling it as C. All of you clear with B?
Yes,
Yes,
sir.
sir.
Yes, sir.
No, the last state, C. So delta C on A. So it's epsilon closure of transition of C. What is C? Q2. So Q2 on A. So Q2 on A, no path, leave it, 5. Transition of C on B. The epsilon closure of delta C, which is Q2 on B. Is there any path? Q2 on B? No, 5. So lastly, delta of C on C. Epsilon closure of delta of Q2 on C. Q2 on C itself, no, Q2. So it's ultimately epsilon closure of Q2. What is epsilon closure of Q2? The state C. Okay, that's it. All the new states have traversed over the input. Clear? Now you need to construct DFA with the given data. What are the states?
A, B, C.
A, B, C.
So the new states are A, B, and C. So A, B, C. Now come to the case of A. A on A itself, right? All of you clear with this path? A on A itself, A. A on B. Are you following this?
Yes, sir.
Okay, just I'm traversing the path now. A on A, A on B, B. A on C is C. So A on C, C. No. Done with it. Come to B. B on A. There's no path. B on B, B. So it's like a self. So B on B. B on C, C. So from B on C, your region C. B is done. Come to C. C on A, no path. C on B, no path. C on C, C. Okay. Otherwise, got it?
Yes, sir.
So this Epsilon-NFA is converted into DFA. 3 simple steps. Compute epsilon closures, make them, mark them new names, for the new states A, B, and C. Traverse over the input. Traverse new states over the input A, B, C. Okay. With this, the new paths have been came on. So with this new paths, make the DFA. Now, step 3, marking of the final state. So in the original NFA, what is the final state?
Q2.
Q2. So in the original NFA, Q2 is the final state. But even though we are calling it as ABC, the actual representation is like this. Okay, you have to view this as Q0, Q1, Q2. Okay, and B as Q1, Q2, and C as Q2. Now, the same logic. Whenever there is occurrence of final state, that is the new final state. So A is having Q2, B is having Q2, C is also having Q2. So all the three becomes final states. Okay. So A is my final state, B is also my final state, C is also my final state. A DFA can have multiple final states, so no issue with this. Okay, ma? See, ma, actually the name is A, but it's actually Q0, Q1, Q2, ma. Q2 is the final state. So my A is also one final state. B, actually it is Q1, Q2. So Q2 is the original final state. So that's why QB is also final state. C is Q2 itself, which is the final state. So that's why all the three are final states. Okay. That's clear?
Yes, sir.
Yes, sir.
In some cases, the examiner may ask you to represent the DFA along with dead states. DFA along with dead state. So in this case, what you need to do is, let me change the, yeah. We have left out the phi path, right, ma? The null path we have left out. B on A, nothing. So while asked about dead state, what you need to do is B on A, okay, B on A, you make a dummy state, D, or a dead state. Okay, some state D, and you just make the phi path. So B on A, nothing. So make it to dead state. So in the same case, C on A, C on B. C on A comma B, it is going to a dead state D. So this is DFA with dead state, ma. The previous, the red one, previous, I mean DFA without dead state. Now you can ask me, sir, with this A comma B, it has converted as an NFA. Okay, don't worry, ma. The actual DFA is only this one. We don't consider about the dead state. Okay. See, until the black portion, we can only see the DFA, ma. But only if the, I mean, issue with the dead state comes, it has become NFA. Okay, so that's why by default, I mean, you need not consider the dead case, ma. But if the examiner asks in such a fashion, represent the Epsilon-NFA to DFA along with the dead state, then you need to draw like this. Okay, the phi path I have taken, ma, nothing new. B on A, nothing. So from B on input A, I am going to some dummy state. I named it as D. This is dead state. And I have told you DFA can contain dead state. A dead state is a state in which only you can reach, but you cannot go out of it. See, only incoming arcs will be there, no outgoing arcs will be there. So B on A, phi. B on A, make it a dead state. C on A, C on B is also going to phi. So from C over the input A comma B, make it to the dead state. Clear, everyone?
Yes, sir.
If only Epsilon-NFA to NFA, sorry, Epsilon-NFA to DFA is asked, this one is fine. This is the actual DFA. If you want to show you the dead states also, the blue one, the extended portion. But you need not worry, as it is like not becoming DFA. Okay, don't worry, ma. Okay, so only Epsilon-NFA to DFA, ma. This is the actual thing. If dead state is asked, you need to go with this. You need not worry about as it's like becoming NFA, because the main scope is this one. Okay, so this is Epsilon-NFA to DFA conversion. I hope everyone are clear. Very simple concept. Okay. Epsilon closures traverse over the input, make it a DFA. That's it. Clear, everyone?
Yes, sir.
Now, moving on to the next concept. Epsilon-NFA to NFA, not DFA. Epsilon-NFA to NFA, non-deterministic finite automata. Okay. Now here I will take some different Epsilon-NFA. So Q0 on A, it is Q1. On epsilon, it is Q2, final state B. Okay. So for this Epsilon-NFA, I want it NFA without epsilon transitions. Okay. Now, step 1, it is same. Compute epsilon closures. Okay. The first step is common, whether it is string acceptance or DFA or NFA. This is common. So epsilon closure of Q0. What will be epsilon closure of Q0?
Q0.
Q0. So as you can see, there is no epsilon path from Q0 itself only. So Q0 on epsilon is Q0. What is epsilon closure of Q1?
Q1 and Q2.
So this is also epsilon. Q2 is also epsilon. So Q1, Q2. What is epsilon closure of Q2?
Q2.
Q2 only. Okay. So these are the epsilon closures. Now, step 2. For each individual state, okay, for each individual state, traverse over the input. That is the only difference. Traverse over the input. What is the input? A comma B. Individual state. This is the difference. So previously in DFA, for epsilon closures, we have merged as one state and we have traversed over the input. But here we take each individual states, the original state Q0, Q1, Q2, we take it separately. That is the only difference. Okay. If you merge the states and traverse, it will become DFA. If you don't merge the state and if you go individually, it will become NFA. That's it. Very simple. So first Q0. The first state Q0. So delta Q0 on what is the first character of input A? Delta Q0 on A. Here you need to append the epsilon for each round. So it is epsilon closure of transition of Q0 comma epsilon A. You have to take this one. Okay, that is the methodology. So we have to append epsilon. So it is epsilon of delta of Q0 on epsilon comma A. Okay. So it's ultimately epsilon of Q0 on epsilon is epsilon closure of Q0. What is epsilon closure of Q0? Q0. So delta Q0 on the input here is A. What is Q0 on A?
Q1.
So epsilon closure of Q1 ultimately. What is epsilon closure of Q1?
Q1 and Q2.
All of you clear with the first step?
Yes, sir.
Okay, for the first state Q0, I'm taking over the input A. So epsilon closure of transition of Q0 on epsilon A. Before A, I'm appending the epsilon input. So,
Sir, but what is the use of taking that epsilon? Because anyway, in the last, you are just removing it. Like directly, we can take Q0 and A, right?
just for computational convenience, that's it. Both are one and the same, but there will be some cases which will have the difference. That's why I will show you in the coming transitions. Okay.
Okay.
So, but for this Epsilon-NFA to NFA, please remember this point. You need to append epsilon. Okay. So Q0 on epsilon, that becomes epsilon closure of Q0. So epsilon closure of Q0 is Q0 itself. So Q0 on input A. So Q0 on A, it is Q1. So ultimately epsilon closure of Q1, which is Q1, Q2. So ultimately Q0 on A is Q1, Q2. This is the one we require. So Q0 on B. So epsilon of delta Q naught on epsilon B. So epsilon of delta Q naught on epsilon comma B. So Q naught on epsilon. So delta epsilon of delta of ultimately Q naught on epsilon. Epsilon of Q naught, which is Q naught. So Q naught comma B. Input B. So anything Q naught on B, nothing, right? So 5. So this is the case of Q naught. Now Q1. So delta Q1 on A. So epsilon of delta of Q1 on epsilon A. So epsilon of delta Q1 on epsilon comma A. So Q1 on epsilon is epsilon closure of Q1. So it is epsilon of delta of what is Q1 epsilon closure of Q1 ma Q1 Q2. So Q1 Q2 on A. So Q1 on A, Q2 on A, nothing, right? So 5. So otherwise, see here now. If I don't take the epsilon closure or if I take the epsilon closure, nothing matters. Right?
Yes, sir.
So without epsilon, if I take A, Q1 on A, nothing. 5 would be the output. Even if I append epsilon, it will become epsilon closure, which is Q1, Q2. One additional state is there, but from Q2 also there is no path over A. Still, it is giving me 5. But there will be some cases which there will be some minor difference. So in order to take that into consideration, I am appending the epsilon.
Okay.
Okay. So now delta Q1 on B. So epsilon delta Q1 on epsilon B. Varun, are you there?
Yes, sir. Yes, sir. Yes, sir.
Okay. It's epsilon of delta of Q1 on epsilon is epsilon closure of Q1. So Q1, Q2. So Q1, Q2 on B. So Q1 on B, nothing. Q2 on B, Q2 itself. So epsilon closure of Q2. So what is epsilon closure of Q2? Q2 itself. Done with Q1. So take Q2. So delta of Q2 on A. It's epsilon closure of delta of Q2 comma epsilon A. Epsilon of delta of Q2 on epsilon comma A. Q2 on epsilon, epsilon closure of Q0. So epsilon of delta of Q2, epsilon closure is Q2 itself. So Q2 on A. Q2 on A, nothing, right? So 5. Delta of Q2 on B. Epsilon closure of delta of Q2 on epsilon B. Epsilon of delta Q2 on epsilon comma B. Epsilon of delta Q2 comma B itself. So epsilon closure of Q2. What is epsilon closure of Q2? Q2 itself. Okay, done. So for each state, I have traversed over the possible input. Now you need to construct the NFA. That's it. What are the states? Same states, right? So Q0, Q1, Q2. Nothing has changed. Same states. Q0, Q1, and Q2. Okay. Now Q0 on A, Q1, Q2. So Q0 on A, Q1, Q0 on A is also Q2, right? Everyone clear with this?
Yes, sir.
So Q0 on A, ultimately it is Q1, Q2. So Q0 on A is Q1, Q0 on A is also Q2. So done. Now Q0 on B, nothing, leave it. Q1 on A, nothing, leave it. Q1 on B, ultimately it is Q2. So Q1 on B, it is going to Q2. Done. Next, Q2 on A, nothing. Q2 on B, itself. Q2 on B. Step 3 is marking the final state. So the same. What is the original final state in the NFA? Q2. So here also Q2 will be my final state. Okay. So here you should not take the dead state. Okay, you can remember the shortcut DFA dead state, DD. Okay, a DFA can have a dead state, whereas NFA no dead state. You should not show dead state for NFA. So just remember the syllogism shortcut. So DFA, there can be dead state and multiple final states. NFA can have multiple final states, but dead states are not allowed for NFA. Okay, that is the functional constraint we had for NFA. Okay, so even though you have a 5 transitions in NFA, you should not represent it with a dead state. Whereas if asked, you should represent for DFA. Okay, only if it is asked, else you can simply ignore it. We require the actual path. That's it. Okay, so this epsilon NFA is converted into NFA without epsilon transitions. Clear, everyone?
Sir, there Q1 is also have epsilon of Q1 is also having Q2, no sir. Then Q1 also will be final state, no? Sir?
You're asking this one.
Both the
That's the difference. In DFA, I have named it as the states to be like this first epsilon closure as A, this is B, and this is C, right? But here that's not the case. I haven't merged any state, right?
yes sir.
అర్థమైందా?
Yes sir, yes.
DFA conversion lo nenu renditni merge chesestunnanu. So that's why if the same this problem is given to DFA conversion, then both Q1 and Q2 would have been my final states because of the occurrence of Q2. But here I'm not merging the states of epsilon closure, right? The same original states Q0, Q1 and Q2 I have taken. Okay. అర్థమైందా?
Sir, understood.
Okay. Just let me summate the things in a tabular fashion so that it will be much more clear to you. So Epsilon-NFA to DFA, that's the first thing. And Epsilon-NFA to NFA. Okay, we have 2 kinds of conversions for Epsilon-NFA. A somewhat easy concept amongst all the first unit concepts. Okay, so first step. What is the first step in both the things,
Closures.
Epsilon closures. Clear, all of you?
Yes,
All of
sir.
you clear on any doubts? Okay, for both the conversions, first step is common. You need to compute epsilon closures. Okay, now second step. For DFA, you have to merge states in epsilon closure. Merge states, or you can simply use the term new states. Okay, all the individual states in the epsilon closure, you have to merge and make it as a new state. Now, in NFA conversion, no merging of states. No merging of states. We will take the original states as it is. Okay, that is the difference. In DFA conversion, you merge all the states in epsilon closure. Okay, how to merge the states based on the epsilon closure? You will merge the states as new states. But here in NFA conversion, no merging of states. The states are taken as individual entities. Now, third, traversing over input. Traversing input. This is same. The third step is same. Traversing input. Okay. Here you traverse the original states. Here you traverse the new states. That is the difference. So here it will be like this. A on A. A is a new state. Here it is Q0 on A. Clear, everyone? Now, fourth step. Based on the data, you go for the DFA construction. Okay. So here, based on the data, you go for the NFA construction. Okay. Now, marking of final states. So in the conversion of DFA as we are merging the new states. For example, it is like this: Q0, Q1, Q2. This is A. I'm taking the previous example, and B, it is Q1, Q2, and C, it is only Q2. In the original NFA, Q2 is the final state. So in DFA, in Epsilon-NFA to DFA conversion, if the original NFA final state is Q2, as we are merging the states of Epsilon-Closure, so whenever there is a final state, all the states corresponding that one final state are treated as final states. So in the previous example, you have seen A is the final state, B is the final state, C is the final state. But whereas for Epsilon-NFA to NFA, we haven't merged any states. So original final state will be as it is. So original final state is new final state. So if it is Q0 in the original NFA, it will be the same Q2. Sorry, Q2 in the original NFA, it will be the same Q2 in the new NFA without epsilon. No, clubbing or anything is done. It is as it is. Now, an additional point is dead states. Okay. So for DFA, if asked, you need to construct the dead states. It's an optional, not mandatory. Every time need not, you can represent the dead state. Okay. Kindly draw the dead state if and only if it is asked. Okay. Don't show your subject prowess there. If the question is Epsilon-NFA to DFA conversion simply, this 5 steps would serve you the maximum marks. No need to go for dead states. If and only if it is asked in the question, show the DFA along with the dead states or along with the 5 transitions or null transitions, then only you should take the dead states. That too, it is a specific for each and every problem. For some states, for some Epsilon-NFAs, you cannot have the 5 transitions. So there is no chance for dead states. I have explained you this point. Not all machines will get the dead states. It is characteristic to some specific machines. So the example that we have taken, Q0 on A, epsilon, Q1, B, epsilon, Q2 on C. This machine has fetched me dead states in DFA conversion. If I have taken the previous example, Q0 on A, Q1, epsilon, Q2 on B. Maybe if I had used this example for DFA conversion, it may not give me dead state. Okay. So this is the comparison between DFA and NFA conversion. You try to convert this to DFA and this example to normal NFA, the same crisscross method. Okay. The DFA example as NFA and the normal NFA example to DFA, these 2 machines. Clear everyone? Ma 3B1, are you clear?
Yes, sir.
Yes, sir.
So this is a simple comparison. The first step is pretty much simple. Epsilon-Closure is common, whether it is DFA or NFA, you are very clear with Epsilon-Closure. So fine. So if DFA, merge the states as 1. In NF, no merging. You can take the original states. Traversing over the input. This is simple. Based on the data, construct a DFA. Based on the data, construct NFA. So if and only first, and if there are 5 transitions in the traversing, you should go for the dead state. Else, you can simply skip it. Here, there is no problem with the dead state. For NFA, no dead state. And marking of the final states. For DFA, whenever there is occurrence of one final state in the new merged state, you should consider it as final state. But whereas in NFA, the original final state of Epsilon-NFA will be the new final state of normal NFA. That's it. Okay. So your task is, for this, I have constructed DFA. So for this, I want you to construct NFA. Okay. And for this example, I have constructed NFA. I want you to construct DFA for this example. That's the task for you. Okay. Thank you all. That's it for today,